Acids, bases and salts. Physical properties of acids and bases. Physical properties of acids. They are sour in taste. They change blue litmus to red. They are corrosive in nature. They produce H plus ions when dissolved in water. Physical properties of bases. They are bitter in taste. They change red litmus to blue. They are soapy to touch. They produce OH minus ions when dissolved in water. Indicators. Indicators are the substances which indicates whether the given substance is acidic or basic by changing color. Types of indicators. There are three types of indicators: natural indicators, synthetic indicators, olfactory indicators. Natural indicators, for example, turmeric, China rose, red cabbage, etc. Synthetic indicators, for example, phenolphthalein, methyl orange. Olfactory indicators, they indicate with the presence of smell. For example, onion, vanilla essence. Chemical properties of acids and bases. Reaction of metal with acid. Metal, when reacted with acid, will produce salt plus hydrogen gas. Metal, when reacted with base, will produce salt plus hydrogen gas. Test for hydrogen gas. When you bring a burning splinter or a candle to hydrogen, it burns out with a pop sound. Reaction with metal carbonate and metal hydrogen carbonate. Acid, when reacted with metal carbonate, gives salt plus carbon dioxide plus water. Test for carbon dioxide. When carbon dioxide is passed through lime water, it turns milky to form calcium carbonate. If excess of carbon dioxide is passed through it, the soluble calcium hydrogen carbonate is formed. Reaction of acids with base. Neutralization reaction. Acid plus base will give salt plus water. Reaction with metal oxide and non-metal oxide. Acids react with metal oxide to form salt and water. Base react with non-metal oxide to form salt and water. All acids dissolve in water to produce or form H plus ions. H plus ions exist in the form of hydronium ions. H plus ions are always written with the suffix aqueous, AQ. Acids conduct electricity in aqueous solution due to the formation of H plus ions. Dry acids does not change the color of litmus because dry acid does not dissociate to form hydrogen ions. H plus ions are always produced in the presence of water. pH. What is pH? pH is a scale which quantifies the concentration of H plus ions. pH is indirectly proportional to concentration of H plus ions. A pH paper is used to find the pH of a substance given. The pH paper is made from the universal indicator. Acids. pH value is between 0 to 6. Neutral. pH value is 7. Bases. pH value is between 8 to 14. Our stomach produces hydrochloric acid that helps in the digestion of food without harming the stomach. During the ingestion, the stomach produces too much acid and this causes pain and irritation. To get rid of this problem, people use antacids, a base, that help in neutralizing the excess acid produced by the stomach. Some examples of antacids: milk of magnesia, Eno, Digen, etc. The calcium phosphate present in our teeth corrodes due to the acid produced by the bacteria present in the food particles stuck in the teeth. Thus, the pH reduces to below 5.5. So, we use toothpaste, a base that neutralizes the acid produced by the bacteria and prevents tooth decay. Our body works with a pH range of 7 to 7.8. When pH of rainwater reduces to less than 5.6, then it is called acid rain. When acid flows into the river, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. When a honeybee stings, it produces formic acid that causes pain and irritation. Stinging hair of a nettle leaf injects methanoic acid, causing burning pain. Use of mild base like baking soda or calcium carbonate on the stung or the affected area helps to neutralize with the acid produced by the plant and the bee and reduces pain. The pH of soil must be 7 for the proper growth of the plant grown on it. If the soil is acidic, then fertilizers are added to neutralize the acid. If the soil is acidic, then calcium carbonate is used to neutralize the acid present in the soil. Dilution of acids and bases. The process of addition of acid or a base to water is called dilution. The concentration of H plus ions in the acid and the OH minus ions in base per unit volume shows the concentration of the acid or the base. By mixing acid or base to water, the concentration of H plus or the OH minus ions per unit volume decreases. Adding water to acid is a highly exothermic reaction and causes severe damage as concentrated acid or a base is highly corrosive. All is well. That is acid to water. What an accident. That is water to acid. Salts. Bleaching powder. Calcioxychloride. By passing chlorine gas through lime water for bleaching cotton and linen in the textile industry, wood pulp and paper industry, and for washed clothes in the laundry. Chlor-alkali process. Electrolytic decomposition of brine solution. It is a strong base. It is also known as caustic soda, also called as lye. Chlorine is collected at the anode and hydrogen is collected at cathode. Baking soda, sodium hydrogen carbonate. Solvay process. By passing carbon dioxide and ammonia gas through brine solution. White crystalline solid, sparing soluble in water, mild, non-corrosive basic salt. What is water of crystallization? Water of crystallization is the number of fixed water molecules present in 1 unit of salt or compound. For example, FeSO4 7H2O, water of crystallization is 7. CuSO4 5H2O is water of crystallization is 5. Na2CO3 10H2O, water of crystallization is 10. Washing soda, sodium carbonate. Heating sodium carbonate. Rehydration of anhydrous sodium carbonate. Uses. Used in paper, glass and paper industry. Used in the manufacture of borax. Used for removing permanent hardness of water. Plaster of Paris. Calcium sulfate, half H2O. Preparation. Heating gypsum at 373 Kelvin. Uses. For making toys, for designing false ceiling, for plastering fractured bones, for making statues. Acid